to the notes for lesson 4.2, multiplying matrices. Now, multiplying matrices is a little bit different than adding and subtracting. You don't have to have the same dimensions, and we're going to talk about what the result looks like. But again, adding and subtracting, we have to have the same dimensions. When we're multiplying, you do not have to. So multiplying matrices, if A is an m by n matrix and B is an n by p matrix, then the product is an m by p matrix. So we look at m times n and n times p, and again, m times p is our answer. So the middle two, the fact that they are both n's, means yes, we can multiply. Remember, this is a row and a column and a row and a column. So the row of the first matrix, so the column of the first matrix and the row of the second matrix have to match in order to be able to multiply. Our result comes from the row of the first and the column of the second. So again, if you write it out like this, the middle two have to match. The outer two are what gives us our solution. So the number of columns in the first matrix must match the number of rows in the second matrix in order to be able to multiply. So if we're looking at these examples, we want to determine whether we can multiply the following matrices. So again, we're looking at the middle here. Since they are the same, we can multiply. And we know that the solution is going to be a 2 by 4 matrix. For part B, notice that 2 and 3 do not match. So you cannot multiply these two matrices. And we say that it is not defined. So example 2, we are multiplying these two matrices. So again, we want to determine what our solution is going to be. So we know that this is a 2 by 2 and a 2 by 2. Again, they match, so yes, we can multiply. And our answer is going to be a 2 by 2. So to multiply matrices, we are going to take the first row and multiply it by our first column. So we are going to take negative 6, we're going to multiply that times negative 1, and then we are going to multiply negative 2 and negative 5 and add them together. We're going to do the same with the second row and the first column. We're going to multiply 0 times negative 1, and we're going to add to that 3 times negative 5. We're going to go back to the first row and the second column. So we're going to take negative 6 times 4. And we're adding to that negative 2 and 3. And lastly, we're going to take our second row and our second column. So 0 times 4 plus 3 times 3. So first we have a negative 6 times a negative 1, which is a positive 6, plus negative 2 times negative 5 is a positive 10. So 6 plus 10 is 16. Underneath that, 0 times negative 1 is 0, plus 3 times negative 5, which is negative 15. Top right, negative 6 times 4 is negative 24, plus negative 2 times 3, which is negative 6. So that gives us a negative 30. And lastly, we have a 0 times 4, which is 0, plus 3 times 3, which is 9. So our final solution is this 2 by 2 matrix. Example 3, we have a 3 by 1 matrix and a 1 by 3 matrix. Again, looking at the center, they do match, so we can multiply them. Our solution is going to be a 3 by 3 matrix. So again, first we are going to take our first row times our first column, so 4 times 2. Next we take our first row, second column, which is 4 times 9. Next we take our first row and our third column, which is 4 times 1. We're going to do this with all of our rows. So next we're going to do 3 times 2, 3 times 9, 3 times 1. And our third row times our first column, so 6 times 2, 6 times 9, and 6 times 1. So our solution is 4 times 2, which is 8, 4 times 9, which is 36, 4 times 1, which is 4, 3 times 2 is 6, 3 times 9 is 27, 3 times 1 is 3, 6 times 2 is 12, 6 times 9 is 54, 6 times 1 is 6. So again, notice that our solution is a 3 by 3 matrix. Next example, our first matrix is a 1 by 3. Our second is a 3 by 1. Again, notice that they are the same, so we can multiply. And our solution is going to be a 1 by 1 matrix. So again, we're going to take our first row times our first column, 2 times 4. Remember, we're adding them together. 9 times 3, and 1 times 6. 2 times 4 is 8. 9 times 3 is 27. 1 times 6 is 6. So our final answer is 41. And again, our solution is a 1 by 1, so it's just one number. Now, notice these two matrices that we just multiplied together. So we took 4, 3, and 6, and 2, 9, and 1, and we multiplied them, but we just multiplied them in a different order. So one solution gave us a 3 by 3, the other gave us a 1 by 1. So notice that for matrix multiplication, it is not commutative. If you remember from chapter 1, commutative means that we can change the order. So remember, in addition and multiplication, we can change the order and it doesn't change our answer. However, this is not true with matrices. When we multiply matrices, the order does matter. Example 5 says, given the following matrices, perform the following operations. So we have two different matrices here, A and B. We are going to be using adding, multiplying by a constant, and multiplying matrices. So we're going to combine both last section and this section to evaluate each of these matrices. So part A, we are doing A times the quantity A plus B. So the first thing we want to do is what is in the parentheses. So we first want to add matrix A and matrix B, and then we're going to multiply it by A. Then for part B, you're going to multiply matrix A times matrix B. And then for part C, you're going to multiply A and B, or you're already going to have that solution from part B, and you're going to multiply that times 3. So like we did in the last section, I want you to pause the video. I want you to attempt these 3 problems, and then we'll go over the answers as soon as you start the video back up. So for part A, we first want to add matrix A and matrix B. So we're going to take -1, 2, 6, and -10. And we are adding to that -1, -2, 0, and 3. -1 and -1 is -2. 2 and -2 is 0. 6 and 0 is 6. -10 and 3 is -7. So we're going to take this matrix and we're multiplying that times A. Now remember that order matters, so we're going to put A in front. So we have -1, 2, 6, and -10. Now we have a 2 by 2 matrix times a 2 by 2 matrix, so our solution is also going to be a 2 by 2. So again, we're going to start with the first row times the first column. So -1 times -2 plus 2 times 6. So then we're then going to multiply the first row times the second column. So -1 times 0 plus 2 times -7. Next, the second row times the first column. So 6 times -2 plus -10 times 6 And lastly, our second row times our second column. So 6 times 0 plus negative 10 times negative 7. So we get negative 1 times negative 2, which is a positive 2, plus 12 is a positive 14. Negative 1 times 0 is 0. 2 times negative 7 is negative 14. 6 times negative 2 is negative 12. Plus negative 10 times 6, which is a negative 60. So that gives us a negative 72. And lastly, 6 times 0 is 0. Plus negative 10 times negative 7, which is a positive 70. So this is our final 2 by 2 matrix. Again, check your answer. Make sure that that is the matrix that you got. Next, we're multiplying matrix A times matrix B. So again, a 2 by 2 times a 2 by 2. So our answer is going to be a 2 by 2. Multiply again. First, we start first row, first column. Negative 1 times negative 1 is a positive 1. Plus 2 times 0, which is 0. First row times second column. Negative 1 times negative 2 is a positive 2. Plus 2 times 3, which is 6. Then we're going to take our second row in our first column. 6 times negative 1 is negative 6. Negative 10 times 0 is 0. And lastly, our second row, second column. 6 times negative 2 is negative 12. Negative 10 times 3 is negative 30. So our final answer is 1, 8, negative 6, and negative 42. Lastly, we're going to do 3 times A times B. So we already got A times B in part B. So that is 1, 8, negative 6, and negative 42. And we're simply multiplying that by 3. So if you remember from section 4.1, we just multiply 3 times everything inside the matrix. So we get 3, 24, negative 18, and negative 126. So those are our final answers circled in black. Again, check your answers. Make sure that those are the answers that you got. The last example, I want to look at a real life example of using matrices. Again, matrices are a way to organize data in rows and columns. That makes sense. So for example 6, the number of calories burned by people of different weights doing different activities for 20 minutes are shown in the matrix. Show how matrix multiplication can be used to write the total number of calories burned by a 120-pound person and a 150-pound person who each bicycled for 40 minutes, jogged for 10 minutes, and then walked for 60 minutes. So again, let's go back to our problem, figure out what information we have. Notice we have our matrix here. We have the calories burned for each pound of people, and then we have our 3 different activities. Now remember, they're doing each activity for 20 minutes. So if they're biking for 40 minutes, again, they want to do each activity for 20 minutes. So that would be 2, because 20 times 2 is 40. They're jogging for 10 minutes, so that would be half, because 10 is half of 20. And they're walking for 60 minutes, and they're walking for 60 minutes, so that would be 3, because 3 times 20 is 60. So we want to make this into a matrix. Now it matters what order we put these in. So we first want bicycling. We said that if someone is on a bike, that would be 2, because 2 times 20 is 40. Next we have jogging, so that would be 1/2 or 0.5. And last we have walking, which is 60 or 3. We're going to multiply that times our matrix. Notice our first matrix is a 1 by 3. Second is a 3 by 2. So notice we can multiply. Our solution is going to be a 1 by 2 matrix. So again, that should be the answer or the totals for each pound of person. So we're going to take our first row times our first column. So 2 times 109 plus 0.5 times 127 plus 3 times 64. Then we're going to take our row times our second column. So 2 times 136 plus 0.5 times 159 plus 3 times 79. If we add all those up, we get 473.5 and 588.5. Now again, if we go back to our original problem, that means that someone that weighs 120 pounds will burn a total of 473.5 calories if they do those 3 activities for the designated amount of time. And for a person that is 150 pounds, they will burn 588.5 calories for those 3 activities as well. So again, a matrix is just a way of organizing data so that we can easily perform operations on it.